Hi, this is Alex from devstories.eu. NumPy, Episode 7 of 7. With modern GPU frameworks handling the heavy lifting in machine learning, you might think NumPy is becoming obsolete. You might even assume that converting a PyTorch CPU tensor to a NumPy array requires a slow memory copy, dragging down your pipeline. Neither is true. The reality is that NumPy acts as the universal translator, interoperability, holding the entire Python data ecosystem together. Think about a standard machine learning pipeline. You use Pandas to load and clean a massive tabular dataset. You extract those values into NumPy to apply a specialized mathematical filter. Finally, you pass that filtered data into PyTorch to train a neural network. If each of these libraries isolated their data, moving from step to step would mean duplicating the entire dataset in memory over and over. You would exhaust your RAM and waste processing time just moving bytes around. Instead, through the magic of interoperability, the data never actually moves. Pandas, NumPy, and PyTorch simply share the exact same underlying memory pointer. When PyTorch reads the data, it is looking at the exact same physical memory addresses that Pandas originally allocated. This zero-copy sharing is made possible by standard memory protocols. The foundational one is the array interface. If a Python object exposes this interface, it essentially hands over a small dictionary of metadata. This metadata tells NumPy exactly where the raw data starts in memory, what shape it takes, and what data type it holds. When you call a NumPy function on a compatible object, NumPy reads those instructions and wraps its own array structure around the existing memory block. It does not create a new array, it just creates a new view of the old data. Here is the key insight. The original array interface was designed primarily for standard system memory. As data science moved to hardware accelerators, the ecosystem needed a way to share data living on GPUs or custom chips without routing it back through the CPU. This led to the adoption of DLPack. DLPack is a modern open standard for sharing multidimensional arrays across different frameworks. It defines a stable structure that any library can produce and consume. If you have a tensor in a framework like PyTorch or JAX, you can export it using the DLPack protocol. NumPy can then seamlessly ingest it using its dedicated from DLPack function. While NumPy itself mostly operates on the CPU, its support for DLPack means it can act as the central routing hub. You can hand a DLPack object from a deep learning framework to NumPy, or from NumPy back to a framework, all without expensive data duplication. NumPy long ago stopped being just a math library. It is the invisible memory standard that prevents the Python data ecosystem from fragmenting into isolated, incompatible islands. I encourage you to explore the official documentation, try these zero-copy conversions hands-on in your own terminal, or visit devstories.eu to suggest topics for our future series. That's all for this one. Thanks for listening and keep building.